हेलो एवरीवन, आज हम सॉल्व करेंगे CSIR नेट फेब 2025 का ये क्वेश्चन विच इज़ क्वेश्चन ऑफ पार्ट सी एंड क्वेश्चन आईडी इज़ 704181. So question is, if U is the solution of the Volterra integral equation given like this, then which of the following condition you will satisfy? So now you can see this is a Volterra integral equation and U is the solution. We know that for a Volterra integral equation, solution is given by u of x is equals to f of x plus lambda 0 to x resolvent kernel into ut, not ut, it's instead of ut it will be ft dt, where fx is this function, lambda is the value that comes before this integral, here it is 1, and resolvent kernel is given by r of x t lambda summation I is from 1 to infinity lambda power I minus 1 k I x comma t. So this is our formula. So now what we have to do, we have to just find the resolvent kernel. Once we know the resolvent kernel, we can substitute in this to find our solution. So the formula for iterated kernels, these are the iterated kernels k1xt, k2xt, etc. And formula for these iterated kernels is k n x comma t is equal to t to x k 1 xz into k n minus 1 zt dz. So we will find each of the kernels using this formula. So k1xt is nothing but the given kernel itself, which is 3 plus sin x, so 3 plus sin t. So this is k of xt and this is k1xt. Now what is k2xt? According to this formula, k2xt will be t to x k1xz into k2 minus 1 is k1 zt. So k1xt, k1xz into k1 zt. So xz will be sin x into zt, k1 zt. Now this will be cancelled out. So now you will see this will be nothing but 3 plus sin x upon 3 plus sin t will come outside of the integral, because the integral is in the variable z and the value of the integral will be z, which will be from x t to x, so it will become x minus t when we will put the value. So this is k2xt. Now we will find k3xt. So after calculating some steps, you will start seeing some pattern in the value of kixt. So you can just write that particular form. So you can see it is x minus t. Now we will see k3xt. It is t to x k1 xz into k2 zt dz. So you put this value t to x. What is k1xt? This is 3 plus sin x upon 3 plus sin z. And what is k2 zt? It is this value, which is 3 plus sin z upon 3 plus sin t into z minus t dz. Right? This gets cancelled out. This again comes outside. Now when you'll see this will be z minus, so what will be this value? This is z minus t. So this is, if you will integrate it, it is z square by 2 minus tz. So you will put it from t to x, it will be 3 plus sin x upon 3 plus sin t. If we'll put x here, it is x square by 2 minus xt minus t square by 2 plus t square. So if you will evaluate it, you will get 3 plus sin x upon 3 plus sin t into, this will be minus t square by 2 plus t square, so this will be plus t square by 2, and if you'll take this, it will become 2 factorial, it will be x square plus t square minus 2xt, which is x minus t whole square. So if you will see, this is looking something like a pattern. So if you will evaluate k for xt, it will be like x minus t cube by 3 factorial. So you try evaluating that, you will get that cube. So this is coming in this form. Ki xt is 3 plus sin x upon 3 plus sin t into x minus t raised to power I minus 1 by I minus 1 factorial. So you will get this form. When you will solve the iterated kernels, you will always find the solution in like this kind of form. There is some function of to the power I minus 1. So when you will find resolvent kernel, it will be summation I is from 1 to infinity lambda power I k I minus 1 x comma t. Is it I minus 1 or something else? Okay, k I lambda power I minus 1, sorry, kx ki xt. So when you will put this, so here lambda is 1, as you can see this value is 1, so you can put it to be 1. So 1 into ki xt, which is 3 plus 7 sin x upon 3 plus sin t into x minus t raised to power I minus 1 by I minus 1 factorial. So when you will do the summation on I, so you will get 3 plus sin x upon 3 plus sin t common, and you will, when you will find like it will be I is equal to 1, so this will be 0 1. When you will put I is equal to 1, this will be like this. So this whole will become e to the power x minus t. So resolvent kernel will be e to the power x minus t into 3 plus sin x upon 3 plus sin t. So since this is a part C question, it is consuming a little bit of time. So when you will, now you will put this resolvent kernel over here to find the value of ux. So ux is equal to f of x. What is f of x? F of x plus lambda resolvent kernel into ft/dt. So f of x is 3 plus sin x. 3 plus sin x plus lambda is 1 and 0 to x. Instead of kernel, you will have resolvent kernel, which will be this e to the power x minus t 3 plus sin x, also this is sin t, upon 3 plus sin t ft/dt. So now ft is this, so you will put it 3 plus sin t in numerator dt. So this gets cancelled out and we are left with this. So now you can take it out, plus 3 plus sin x can come out because integral is in t, and e to the power x can also come out. So when you will integrate with respect to e raised to power minus t, it will be e raised to power minus t minus 1 0 to x. So your ux will be 3 plus sin x plus e to the power x 3 power sin x and e to the power minus x with a negative sign plus 1. So this is your answer. So now we have to check. Okay, we can first simplify it, then we will check the option. Plus 3 plus sin x, we will take this e to the power x over here, it will be minus 1 plus e to the power x. So when you will take 3 plus sin x and you will take minus 3 minus sin x, this gets cancelled. You will just get e to the power x 3 plus sin x. So your ux is e to the power x into 3 plus sin x. Ux is equal to e to the power x 3 plus sin x. Now you check the options. So option 1 says u pi by 2 is 4 e to the power pi by 2. So u pi by 2 is e to the power pi by 2 into 3 plus sine pi by 2. Sine pi by 2 is 1, so it is 4. So this option is correct. So u pi, it says 3 e to the power pi. So sine pi is 0. This is e power pi. So this is also correct. What is u e to what is u minus pi? So you put minus pi here. It will be 0. 3 into e to the power minus pi. So this is wrong because here it will be only 3. What will be u minus pi by 2? You put minus pi by 2. It will be sine minus pi by 2. And sine minus pi by 2 is minus of sine pi by 2, which is minus of 1. So 3 minus 1 will be 2. It will be 2 e to the power minus 4. So this is also wrong. So the correct answers are 1 and 2 for this particular question. I hope you understood the solution and I liked the video explanation. Thank you.